So we're going to look again at Miller Indices, picking up where we left off in another video. But we're going to look at a different case where instead of having all of the axes being intercepted at the same value, so we looked at something that hit A at 2, B at 2, C at 2, so here are A, B, and C axes. Let's take some odd numbers. Let's say that the C axis is hit at 3, and the face intercepts B at 4. And let's say the A is intercepted at 2. And so we have a face that looks like this. It's not necessarily an equilateral triangle. So, and by the way, the numerical values as we go along each of these lengths, so as we measure length along the b-axis or the c-axis or the a-axis, those intervals don't have to be the same. So we can hit number 1 here, but number 1 on the c-axis can be at a very different distance. It doesn't really change the way we compute the Miller indices. So let's write this. We have the intercepts 2a, 4b, and 3c. We'll erase the board and look at how the Miller indices turn out. So we had 2a, 4b, and 3c. Well, what we would do is we would invert these. So we have 1 over 2, 1 over 4, and 1 over 3. We've established the intercepts first, so that's step 1. Now we invert, and then in step 3 we clear the fractions. The easiest way to do that here would probably be to multiply by 12. So 12 divided by 2 is 6, divided by 4 is 3, and divided by 3 is 4. So the Miller indices, if we've done the math correctly, would be 6, 3, 4. So for this odd triangular face that we drew here, it would have the Miller indices, we'll just abbreviate that as m dot I dot, as 6, 3, 4.